This video is going to go through the review sheet that was given out today in class. So we'll start here. State if the three numbers can be the measures of the sides of a triangle. Remember, you want the small plus small to be greater than the bigger side. So here there's 3, there's 8. 3 plus 8, that equals 11. 11 is not bigger than 12, so this is not a triangle. Here, small and small, 7 plus 9, so 7 plus 9 equals 16. 16 is definitely bigger than 12, so this is a triangle. Two sides of a triangle have been given, so find the range for the possible third side. Remember, this is where you'll subtract and then you'll add. So you got x's in the middle, so you do 12 minus 6, which is 6, and then 12 plus 6, which is 18. Same thing over here, so x is in the middle. So 9 minus 9 is 0. 9 plus 9 is 18. Classify a triangle by its sides and its angles. So right away, I can see it has two equal sides. So it's definitely isosceles. And you can see a right angle right there, so it's isosceles, and it's right. All right, this one, all three sides and all three angles are equal, so this is an equilateral triangle. And we can even say it's acute because all of the angles are acute angles. Equilateral is enough, though. Here you got one obtuse angle, so this is definitely obtuse. And then we can see none of the sides are equal, so it's obtuse, and it's scalene. Here we got two equal angles, two equal sides, and we can see that all the angles are smaller than 90, so this is acute, and it's isosceles. All right. Now, beyond just looking at a triangle and determining, we can also use Pythagorean theorem to start to see, are these things acute, obtuse, or right? And remember, we want to do big first. You're going to do big squared, and you're going to compare it to small squared plus small squared. So a little bit different than what we saw at the first few problems here, where we're just trying to see if it's a triangle. These should all be triangles. We just need to compare. So the big side here is 10. So 10 squared, and we're going to compare it to 8 squared plus 8 squared. Well, that's 100. Compared to 64 plus 64 would be 128. That's less than. If we remember to do the big first, the inequality will kind of give us a feel. So since that's less than, that's acute. Next, so the big one's 13. So we're going to do 13 squared. We're going to compare it to 4 squared plus 12 squared. So 13 squared is 169. And then 16 plus 144 is 160. Here's a case where it's bigger, right? 169 is bigger. And that gives way to obtuse. 9, 12, and 15, so there's the big one. 15 squared, and we're going to compare it to 9 squared plus 12 squared. So 15 squared is 225. Excuse me, 225. And we're going to go ahead and 9 squared plus 12 squared is also 225. So those two things are equal, which means this is a right triangle. And then one more example. So 15 squared is the big one. And we'll go 10 squared plus 12 squared. So again, 15 squared is 225. 10 squared plus 12 squared, 244. So 225 is less than would be acute. All right. And then actually using the Pythagorean theorem to solve some of these things, to solve some triangles. So here we're missing b. So we'll do 8 squared plus b squared equals 10 squared. And then work our way through it. So 64 plus b squared equals 100. Subtract 64 from both sides, so b squared equals 36. Don't forget to take the square root. So b equals 6, which happens to be answer choice B. Here we're missing side C. So 9 squared plus 12 squared equals c squared. And this is probably the most straightforward Pythagorean theorem where you're just solving for the missing side. So this is 225 equals c squared. So we'll take the square root of 225, and that is 15. So choice A. And then page 2 of this thing, you're going to actually start doing some of the trig. So we'll use trigonometry. So step 1, remember, we're going to circle the angle. And then x is going to be opposite. 16 is going to be the hypotenuse. So with O and H, we use some old hippie. Caught another hippie. Tripping on acid. That's our easy way to remember it. So since we have O and H, we're going to use sine. Remember the angle, what you circle goes in the parentheses. And this tells us opposite over hypotenuse. So x over 16, and since x is in the numerator, we're going to multiply 16 times sine of 35. So 16 sine of 35 in the calculator, make sure we're in degree mode. So x equals 9.2, which is choice B. Here I'm going to circle the 39, so 18 would be adjacent, x will be hypotenuse. So now we have AH, which is cosine. So cosine, now 39 is in the parentheses. Remember, adjacent goes on top, so 18 over x. X is in the denominator here. Okay. So denominator means we're going to divide. So in the calculator, we're going to do 18 divided by cosine of 39. So here, x equals 23.2, which is choice D. 17 and 18, same thing. We're still using our trigonometry, except now we're going to find a missing angle. So here, circle the angle again. Opposite is labeled, and so is adjacent, which means that we're going to use tangent, right? TOA. So tangent of x, opposite on top, adjacent on the bottom. And since x is now in the parentheses, that means we need to do the inverse, the opposite. So we need to do second tangent, or tangent to the -1. If you've got Desmos, you need to do arctan. So now x is going to be equal to tangent inverse 33 over 38. So x is basically a 41-degree angle. Here, we'll circle the angle. So now we've got hypotenuse, opposite, and adjacent all given. Now you're just going to have to pick which one you'd like to use. I'll just stick with sine because it's the first one. So sine, what goes in the parentheses, right, is what we circled. So that's x. And we would do opposite 55 over 73. Since x is in the parentheses, we need to do the inverse, so second sine inverse, and then just type in 55 over 73. And that is x equals about 48.9 degrees. Now you could have used cosine or tangent with number 18 because I gave you all three sides. I just picked sine because it was first. Right? Ones that we did kind of like yesterday where we're solving the whole triangle. So first things first, I've got two of the sides given to me. I'm missing side B, so I could go ahead and use Pythagorean theorem. 5 squared plus b squared equals 10 squared. So 25 plus b squared equals 100. So b squared equals 75. And square root of 75 is 8.66. So I'll just come over here. So z equals 8.66. All right, and now it's just a matter of picking which one do I want to use. I'll just go ahead and circle x. So we got opposite, there's hypotenuse, there's adjacent. Since the adjacent and the hypotenuse are already marked with numbers, I'm going to use AH, which means I need to use cosine. X is in parentheses. Cosine of x equals A over H. And so since x is in the parentheses, I'll do cosine inverse of 5 over 10. And cosine inverse of 5 over 10. X equals 60 degrees. And that right there is going to allow me to, now we can see that the whole triangle needs to add up to be 180. So 90 plus 60 equals 150, which means 180 minus 150 equals 30. So the missing angle now is 30 degrees. So y in this case is 30 degrees. So I've used Pythagorean theorem to find my side. I've used trigonometry, and then I used the triangle, the angle of a triangle adding up to be 180. And then the final thing, setting up your triangles to do these trig problems with angles of elevation and depression. So here's Brock flying his kite, and then there's the string coming off of it. How much string has he let out? If his kite is 35 feet off the ground, so there's 35, and forms an angle of elevation of 47 degrees. We want to know how much string has been let out. So circle the 47. We got opposite and hypotenuse, which is sine of 47. Opposite on top, hypotenuse on the bottom. And since x is in the denominator, we divide. So 35 divided by sine of 47. 35 divided by sine of 47. So x is equal to 47.86. And again, that should be bigger than 35 because x is the hypotenuse, and sure enough it is. And then the final problem, Santa's headed to Elizabeth's house for present delivery on Christmas Eve. He's approaching an angle of depression of 15 degrees. So this is where we have to remember. Angle of depression is actually the one that's just outside of the triangle. But we can get inside the triangle because the angle of elevation, right, angle of elevation equals the angle of depression. So we can just put that 15 down here where the angle of elevation is. So Santa's current altitude is 175. So we'll draw Santa's sleigh here, and there's some reindeer flying with Santa. Whee! And there's the big man with his awesome hat. And okay, and so Elizabeth was out walking her dog as Santa was approaching the house, and she happened to look directly above her. So here is Elizabeth, and she looks up. Oh, there's Santa. So how far is she from her house? So her house is over here at the other side of the triangle. So that's the x that we're after. So we'll clean this up just a minute. So circle the angle. There's opposite. There's adjacent. OA goes with T. So we want tangent. We circled 15. That goes in parentheses. And then it's opposite, 175, over adjacent, which is x. And again, x is in the denominator, so we will divide. 175 divided by tangent of 15. And that tells us that Elizabeth is 653.1 feet away from her house.